Okay, thank you for joining us today. Today's webinar is on using OCS in VFD applications. And I do want to point out the fact that you do have the ability to ask questions at any time throughout the program, and we'll either answer them during the program or afterwards at the end. Joining me today, I've got a couple of special colleagues. Let's start with Mr. Casey Gardner, applications engineer in our sales group. How's it going, Casey?
Hey, not too bad. How's it going, Chuck?
Going great. Casey is going to be one of the folks who are answering any technical questions that come up during the broadcast. If there's any that we don't get addressed at that point, then I'll be answering them at the end, with Casey's help, I should say. And then also joining us, we have our marketing whiz kid, Marcy Tyree. How's it going, Marcy?
I'm good, Chuck. How are you?
I'm doing great. All right, let's go ahead and get started. Okay, here's our agenda for today. We're going to introduce the topic of OCS and VFDs. What are those three-letter acronyms, of which there are so many in our industry? We're going to talk about typical applications for those products, why those products are a good fit with each other. We're going to talk a lot of not just theoretical type discussions, but we're also going to talk about application details. If you're going to integrate an OCS and a VFD in an application, what are the steps required to do that? After the slideshow, I'm going to demonstrate some of those steps for you from a application setup standpoint in our application development program, Seascape. And then, as I mentioned before, we'll have an opportunity for questions and answers at the end of the session. All right, let's get started. Just starting on a real basic level, what is an OCS? So OCS stands for Operator Control Station. It is the brand name of our all-in-one controller products that we have been selling since 1998. Horner Automation was one of the pioneers in this product category, and we have sold thousands and thousands of these units over the years, and we are definitely one of the leaders in this product category. So an OCS is an all-in-one controller that combines the functionality of control, I/O, whether it's local or remote, with built-in operator interface, along with extensive networking and communications capabilities, again, all in a single and hardware and software package. So that's an OCS, that's a Horner brand name. A VFD is a general term. It stands for variable frequency drive. And this is a type of drive that's used to control AC motors by varying the frequency supplied to the motor. It's certainly one of the most common components used in electromechanical systems out there. And VFDs are often called other things. So it's not always variable frequency drive. They're sometimes called adjustable frequency drives or adjustable speed drives, variable speed drives, AC drives, inverters, a lot of different names for basically the same thing. Okay, so that's just a quick introduction of what we're talking about with an OCS and a VFD. Now, what are the types of applications where you might find VFDs? And we've got a few of them listed here. Pump control is certainly one of the most popular. A lot of advantages to being able to control the motor, a pump motor, in pumping applications of all types. A fan and blower control, another very common application. A conveyor control, whether you're talking about material handling or maybe another type of conveyor, lots of advantages there for controlling conveyor speed, etc. Air compressors, winding type applications, whether you're talking in the paper industry or whether you're talking, maybe the metal industry or another industry for that matter. Injection molding, whether you're talking aluminum or whether you're talking plastic for extrusion. Machining, controlling maybe the feed or the spindle rotation, and literally hundreds of other applications as well. And some of these applications are sometimes used with variable frequency drives, with AC drives. Some of these applications are used with servo drives, but certainly you'll find variable frequency drives in all of these applications. So one of the questions I'm sure you have, or some people may have, is, okay, well, which variable frequency drives, which brands, if you will, work well with OCS? Now, we certainly, as an automation group, do not have a preference. We have sister divisions at Horner that do sell specific brands of variable frequency drives, and we certainly support our sister divisions in those efforts. But when it comes to our customers or our distributors or reps, we try and make sure that our product line as a manufacturer can support just as many variable frequency drive brands as possible. So you'll see a whole number of them on the screen here, and there's even more. So anytime I'm talking about a drive during this presentation, I'm going to be talking about really a general purpose device and not any particular brand. Okay, even in the examples I give at the end when I demonstrate Seascape, it just happens to be from a particular brand, but we have all kinds of other examples that I could give you. Hey, Marcy, while you're at it, why don't you go ahead and send out a couple of poll questions. Let's start with the first one, which we ask about, have you used OCS with a variable frequency drive before? Okay, you can either answer that now or answer it later. I'm going to go ahead and say yes. It's asking me as well, by the way. And then we'll move on from here. And in a few minutes, I'll ask our next poll question. So we've introduced what is an OCS, what is a VFD, where are variable frequency drives used, what types of applications. Certainly, all of those applications we talked about for variable frequency drives, we have numerous examples of OCS all-in-one controllers being used in those applications as well. But let's talk about some of the reasons why these two components are just a great fit together. Well, first of all, they are a complete solution. VFDs are really good at performing motor control, okay, and a whole variety of different applications that we reviewed. And certainly they can do more than strictly motor control, but general machine control is not their strength. So a lot of the things that a VFD doesn't necessarily do all that well, coordinate between multiple parts of a machine, etc. The OCS does that extremely well. Interfacing with a variety of different sensors, whatever the case may be. OCS controllers certainly complement the VFDs by performing well in the areas where maybe the variable frequency drives really just don't do well. Another way in which the two are a complete solution is the fact that while variable frequency drives have I/O built into them and the ability to interface with some different types of sensors and actuators, in general, they're pretty limited when it comes to I/O. And most variable frequency drive manufacturers don't necessarily have a lot of expansion I/O for their drives. They have some, typically, but not a lot. So certainly, having a wide variety of I/O either built into the controller, the OCS All-in-one Controller, or to be able to be added through expansion is certainly a big strength of the OCS. So there are a lot of sensors that you typically wouldn't find interfacing with a variable frequency drive, for instance, where they will interface very well in the case of an OCS. For instance, RTDs, thermocouples, those sort of temperature sensors is a strength for the OCS for sure. Not something you typically would connect directly, at least, to a variable frequency drive. Another way that these two are a complete solution is in the operator interface, because while almost all VFDs have some level of operator interface, whether you're talking a potentiometer with a 7-segment display, whether you're talking about a touchscreen type keypad, they all offer something typically, but not on the level of what is offered with an OCS, where you can choose your screen anywhere from 2 inches up to 15 inches and not just do basic starting and stopping of the motor and controlling speed and parameters and those sorts of things, but you can also, coordinate the entire machine and perform advanced functions like alarm management, trending, data logging, those sorts of things. So certainly another way that the OCS helps make a VFD a complete solution. Now let's start talking about package size, because certainly all the different things I've talked about before, you could make some arguments that an operator interface would be good with a VFD, or a traditional PLC would be good with a VFD. And that's true, but an OCS combines all those capabilities in one in an incredibly compact package. So one of the things that's happened over the last 10 years or so, certainly in the variable frequency drive industry, is the size of the package for the relative capability that package has got significantly smaller. So you can find drives these days in package sizes that you wouldn't even have thought about years ago. You combine that with the fact that you just can't get a more functional all-in-one control product of any kind than a Horner OCS All-in-one Controller. For instance, if just take a look at the XL4 I have on the screen there, we've got a nice touchscreen, 20 to 40 I/O points, complete control capability, all kinds of communication ports, all in a 4-inch by 4-inch by 4-inch cube. Combine that with a compact variable frequency drive, and you're looking at one heck of a compact package. not only has size been shrinking, but prices have as well. While there certainly are advancements in variable frequency drives and controls in general with more power and more functionality, there's also more low-cost products available than ever. And that's true both with the Horner OCS All-in-one Controller and the variable frequency drive. So as an example on the screen there, I've got our Micro X2 controller, just a little bit more than $200. It's got 30 I/O built into it, complete control capability with a modest operator interface built in, and the ability to connect and control a variable frequency drive over RS-485 and still do advanced features like data logging, for instance. So from a cost standpoint, again, another good match between the two. Now let's start talking about connectivity between the OCS and variable frequency drives. There are a variety of ways that you can control a VFD. The most common, beyond just turning a pod or entering a number on the keypad, which is pretty much a manual process, more common than that, of course, and more automatable, if you will, is using I/O signals connected to the terminal block of the drive to start and stop, change direction, adjust the speed, those sorts of things. And the OCS has all those signals built in. So we've got, a dozen or more models, well, more than a dozen actually, that all have enough I/O built in to very comfortably control one or more variable frequency drives with I/O alone. Okay, so that's another way that you can interface the two together really well. And then not only can you control a VFD through I/O, you can also control it using RS-485. Typically, in the lower cost models, that is through Modbus RTU protocol, and that feature, that communications port, is standard in every OCS that we sell. So again, another reason we've got a good fit there. And then in addition to the basics of Modbus Communications, we also support some slightly more advanced communication options, including communicating over Ethernet for those drives that support it, as well as CAN open for those drives that support it as well. There are certainly some advantages to Modbus TCP, for instance, which is a little bit easier to work with than Modbus 485. And CAN open has some advantages in terms of some communications rate as well as synchronization functions that you won't necessarily find with a typical serial communications protocol. So in addition to the I/O connection, we've also, for basic start, stop, and speed control capability, you've got the ability to add either a full-blown Ethernet or field bus based network connection, or a basic RS-485 Modbus RTU connection to not only start and stop the drive and adjust speed, but also to get complete diagnostics in terms of fault codes and those sorts of things. Live statistics in terms of torque readings, current readings, bus voltages, all are available through those connections. Okay, so we've talked about, in general terms, we've talked about why these two components are a good fit for each other. Now let's talk about some of the nitty-gritty and the details about how you would go about setting up these two components to talk to each other. Okay, looks like we've got another poll question that is popping up here from Marcy. If you have used any of these brands before, go ahead and answer. Appreciate your feedback. Okay, so let's take a look at an overall map of the application process here on this slide. So here's the steps we're going to go through, and I'll go through each of these in detail, and then I'll demonstrate the software setup side on the back end. We start by designing the electrical interface, connecting the communications cabling. There will be some parameters that we'll need to set, typically from the keypad on the variable frequency drive. We'll need to get that user's manual out for the drive, examine the parameter list. It's amazing to me these days how many parameters you'll find in a drive, literally hundreds and hundreds of parameters. Sometimes finding the 2 or 3 that you're looking for to get started can be a bit of a challenge, but most drive manufacturers are doing their best to make that process a little bit easier, at least. Next, you'll be setting up communications on the OCS side of things in Seascape, for instance. And then lastly, you'll be going through the process of writing and testing your application from a machine control standpoint, programming any screens that you may want to develop with live data and set point adjustments, et cetera, and diagnostics, for instance, And then if you have any other functions you want to perform, maybe you want to log data from the drive, maybe current readings or torque readings or whatever the case may be, those are all available. So that's a map of the application process. We're going to kind of go through each step now, one by one. Okay, let's start with the electrical interface. Okay, so for most applications, we do recommend that you have at least some signals hardwired between OCS I/O and the variable frequency drive. Now, that's not an absolute necessity. You could completely control a drive over a communications network. You could certainly do that. But in most applications, especially relatively small ones, it's usually a good idea to have some hardwired I/O for things like starting and stopping, changing direction, adjusting speed. Sometimes it's just more convenient. You know that regardless of the communication status, you're going to be able to start, stop, change speed, whatever the case may be, at least have basic control functionality. Okay, so that's a recommendation we typically use. Now you're going to use digital signals for starting, stopping, and changing direction. If you have the option, and most drives do give you the option, you should probably use PNP type signals if possible. You can use NPN. It's not like it's not an option. It's just that PNP is more common, and generally it's a little easier connection than NPN, at least from the standpoint of interfacing with PLCs these days, or in our case, a OCS All-in-one Controller. For controlling motor frequency, if you decide to hardwire that connection, typically those are usually done with 4 to 20 milliamp or 0 to 10 volt signals. If you take a look at it strictly from a noise standpoint, electrical noise I'm talking about here, you're best to use, or you're advised to use, shielded wiring. So typically a shielded twisted pair in the case of an analog. You definitely want to handle that shield drain properly by making sure that the shield drain is connected to a good solid earth ground on one direction only, or I'm sorry, on one end only. And the advantage of 4 to 20 milliamps over 0 to 10 volts is it's a little bit more noise immune. Another thing that you'll find from time to time is for controlling drive speed or drive frequency, some drives also support a pulse type input, often in a PWM format where it's looking for a fixed frequency with a variable duty cycle, or maybe even in some cases where a variable frequency on the input signal will cause the frequency of the motor to be changed in a proportional fashion. So that's another option you'll sometimes see in the case of controlling frequency from a hardwired signal as an alternative to an analog signal. All right, so we've done a little bit of hardwiring in most applications. Again, not absolutely necessary. The next step is typically to select the communications interface. And in reality, there's no absolute ironclad requirement that you connect a communications interface between the drive and the OCS. You could strictly use I/O connections. Now, if you do that, you're going to be limited to strictly, start, stop, speed control, those sorts of things. You're going to not have access to any kind of diagnostics or real-time data, those sorts of things outside of what you've hardwired. So we typically do recommend that you go ahead and connect the network. It's there. You might as well use it. So which network are you going to choose is the big question, right? Because you could choose RS-485 Modbus, which is built in to most drives. You could choose an Ethernet-based connection like Modbus TCP, for instance. You could use a field bus type option like CAN Open or EtherCAT or something of that nature. And right on cue, Marcy has popped up another poll. So if you'd like to answer that, we'd appreciate it. So once again, there are some factors in terms of which network you choose. So if cost is the primary driver, it's a low-cost application, then probably RS-485 Modbus is going to be the approach. Strictly because it's built in for free to just about every drive manufactured out there today. And while it doesn't have the absolute top of the line from a performance standpoint, it's highly functional. Now, if the application can afford it, a little bit of extra, because it's usually not 100% free from a drive standpoint, then bumping up to Modbus TCP is a good idea. Oftentimes, it adds a bit of speed and a bit of ease of use. The wiring is certainly simpler as opposed to having to wire up point-to-point wiring. However, you do have a requirement then for a Ethernet switch, and other components similar to that. But again, if the application can afford it, certainly I would recommend going with a Modbus TCP type approach, for instance. Now, another factor could be synchronization. So you might have multiple motors that need some level of synchronization. If that's the scenario, then CAN open is a good choice. I know a lot of people don't think of CAN open communications when they think about variable frequency drives. CAN open is a very popular field bus network that is extremely popular in Europe. A lot of drive manufacturers support CAN open, some of them even natively as built in, even without extra cost. I know that Lenza offers that as a standard option on many of their drives in addition to Modbus. So CAN open is an option you should not forget about. Now, it certainly is more complex, and I'm not going to cover all the details of setting up CAN open with a drive here, but we absolutely have examples that we can share with you for doing that with a couple different drive manufacturers. So again, it is the most complex connection. It was certainly when compared with Modbus or Modbus RTU, but it does offer a level of synchronization that you're not going to find with those other two choices. Okay, now once we've selected the actual field bus or communications connection, now we've got to get the cabling right. And all these details you see here on the screen, this is all about the cabling details for Modbus RTU over RS-485, which is far and away the most common electrical interface between a PLC or a OCS in this case and variable frequency drives. So from an Ethernet standpoint, if you were to choose one of those networks, now you're talking about traditional Ethernet type communications cabling where you wire from each component back to a switch. You're all pretty much familiar with that. From a CAN open standpoint, CAN open is typically a daisy chain using special CAN cabling, but I won't cover that in a lot of detail. What I am going to cover, because of the commonality of it, is the RS-485 wiring over Modbus. So you start off with typically two pairs is usually what you'd like to have. So you'd like to have a communication cable that features two twisted pairs. And you're going to use the first pair of wires for the signal pair. Sometimes that's labeled A and B. That's technically what the RS-485 standard instructs you to label the conductors, but they don't always, not all manufacturers follow that. You'll often see it labeled as plus and minus, sometimes D0 and D1, whatever the case may be. Typically in the data pair, you'll have two conductors that are identified. And then you really should have a third conductor, which can be just one of the wires in that second pair, to act as your common. Because what that will allow to happen is it will allow you to overcome any common mode issues between objects on the network or devices on the network, including the OCS and the individual drives. So certainly there are drives that don't even show connecting up that third common wire on RS-485 at all, but be aware that you could have common mode issues in that scenario. Now, you're going to daisy chain all the components on the network. So if it's just an OCS and one drive, it's basically the equivalent of point-to-point wiring. If you have multiple drives, for instance, you're going to be using a daisy chain approach like in the diagram. You need to make sure, whether it's just two devices or four, like I've shown here, or even more, the devices on the end of the network should be terminated. Now, if the OCS is at one end of the network, okay, then the OCS has the ability for doing termination outside of the cable. So in the case of the XL7 that we're showing there, that and some other similar products, or similar models, I should say, have dip switches for setting termination, whereas some of our other models have a bit that you can set from the system menu or from your application program that turns on and off the RS-485 termination. So you need to make sure that both ends are terminated. Now, the way RS-485 half duplex works, and that's what you're going to find here with the Modbus RTU in almost every case, is that both devices are using the same pair of wires, that signal pair, to communicate. And at any given time, either one device will be communicating, say the OCS, or the other device will be communicating, one of the drives, or neither if you're in between. Now, sometimes in that scenario where there's no device that's communicating at any given instant, in some scenarios, you can get some, I guess we'll call them spurious ones and zeros that may fly around from time to time when no device is driving the communication bus. And if that is the case, then there is a feature called biasing, which you can turn on in the OCS from the system menu, which will apply a pull up and a pull down register internally, invisible. You don't see them, but they're there. And that will typically get rid of any spurious ones and zeros that are occurring while the network is otherwise idle. But you would always start off with biasing off. And then if you need it because you're having communication issues or corrupt communications, then you would turn it on later. But generally, you start off with it off. Okay, so we have wired up our network in that previous step. And again, we're talking primarily about RS-485 Modbus here because that is the most common. The next step, regardless of the communication network, is there are going to be some parameters that you're going to have to set in the drive, almost certainly, to enable communications or to adjust communications or whatever the case may be. And it's very possible that the default parameters will just work. That could happen, but it doesn't always happen that way. So you'll need to check the drive manual and look for the communication settings that you'll need to adjust to get communications going. Examples of this would be the ID in the case of Modbus, the baud rate, which usually you're going to want to try and use the defaults for the drives and just adjust on the OCS side, but you may want to adjust on the drive side as well. But there'll be a number of parameters that you will need to adjust on the drive side from a communication standpoint. Now, in addition to that, there almost certainly will be parameters that you need to change that aren't directly related to communication necessarily, but are related to where is the drive looking for its start-stop signal? Is it looking to the terminal strip? Is it looking to its own keypad and potentiometer that may be wired to it? Is it looking to the network for those functions? And almost all drives have parameters that allow you to select where those start-stop signals and speed control signals are coming from. So those will need to be adjusted through drive parameters as well. And again, a hint I would use just as old applications engineer is leave as many parameters as possible at the default settings. It'll make it easier not only on yourself when it comes to setting up the system the first time, but if you ever need to swap out a drive or the electrician ever needs to swap out the drive later, he'll thank you because there'll be less parameters to change on the drive side. Now, that being said, when there are parameters that you want to change to get the machine to operate better, that's another scenario. But if you're, not sure if you should change it or not, it really doesn't affect the operation of the machine. My hint to you is leave it as many defaults as you can. So the next step now that we've adjusted the drive for its communication parameters, as well as where it's looking to get its control signals, you're going to want to take a look at that really thick, now it's thick only from an online standpoint, that thick VFD manual and take a look at the parameter list. Okay, because there are some parameters you're going to need to find in order to be able to successfully interface with the drive. Whether that means you're strictly adjusting frequency over the network or whether you're just monitoring parameters or faults, whatever the case may be, the drive is going to have a whole host of parameters that are accessible, and usually a bulk of them are accessible over the network. So you're going to want to be familiar with A, what parameters that you care about for the application, and B, which parameters you may want to occasionally access, maybe from an operator interface screen, as opposed to parameters that you're going to want to monitor and or change on a live, real-time basis. Okay. In addition to identifying the parameters that you want to work with in the drive over the network, you're also going to want to take a look at how those parameters are scaled, for instance. So let's talk about frequency, the motor frequency. You'll find variations between manufacturers in terms of how motor frequency is reported. Some manufacturers report it in tenth hertz. Some manufacturers report it in hundredth of a hertz, and some manufacturers do it a different way. So the scaling information is also critical so that you can make sure that the data that you're reading and writing between the OCS and the drive is truly apples to apples. Okay. And then if there's any processing that has to happen, any scaling that has to happen on the OCS side, maybe on the screen or maybe in the logic, you're going to want to make sure you make a note of that as well. And then again, document the key parameters that you want to work with and that you want to map permanently between the OCS and the drive, and those that maybe you want to access on an occasional basis. And then you're going to continue to take a look at those parameters, not just from the standpoint of scaling and where they're located and those sorts of things, but from a Modbus standpoint. Again, we're talking primarily Modbus here. What is the Modbus address that I'm going to use on the OCS side to be able to access these parameters? And there's a variety of different ways in which Modbus data is presented in the user's manual. Now, when I show you the OCS configuration, hopefully you'll see that we've done the best we can to try and make what you configure on the OCS side from a Modbus standpoint match what the drive has listed in its manual from a Modbus standpoint. So we've given you some options on the OCS configuration end to try and make things match. But it's really important for you to understand what the format looks like. So for instance, the most common Modbus address style, if you will, is 5-digit addressing, where the most common parameters called holding registers, which is where you'll find a lot of the information from drives, is typically mapped starting at register 40,001, 40,002, 40,003, etc. So you may find that in the user's documentation. Well, or you may not. You may find instead with something that is just a number starting as 0. For the same parameters, instead of starting at 40,001, they may just be shown as 0, 1, 2, etc. And the key is if that is a 0-based number that they're starting with or a 1-based number that they're starting with. If they're starting with a 0-based number, then that really isn't an offset that isn't an address per se, but an offset. An offset from the first register in the group, which happens to be the number that gets transmitted over the wire. If you were snooping in with a communications monitor, you might see 0 instead of 40,001. But in the manual, you might see 40,001. So again, there's different styles in which drive manufacturers list their Modbus addresses. It could be in decimal, 5-digit modicon. It could be a 4-digit offset that's in decimal, or it could be a 4-digit offset that's in hex. So you want to pay attention to that. Okay, and then the last step really, well, I guess it's next to last step, is to set up the communications on the OCS side. And I'm going to show you these steps live with Cscape. Again, we're going to start in the hardware configuration, select our serial port, set it up for Modbus RTU. Again, we're giving you more of the details on the Modbus side just because it's the most common. You're going to go and do some configuration of that Modbus protocol on the OCS side. First of all, at the network level, adjusting pull rates, timeouts, etc. Again, I'll cover this all for you live here in a minute. You're going to have some device level configuration. For this, each drive that the OCS is talking to, what's its ID? What format is its Modbus address in to make it easier on you to enter in parameters? And then you're going to create what's called a scan list, which is going to be real-time data that the OCS is going to monitor on a continuous basis out of the drive and then place in local OCS variable space or register space so that you can access it anytime you want. And then if you ever want to change it, for instance, the speed set point or something, the OCS will write it back again if it's a writable parameter. So those are the steps involved. Now, once you've set up your communication, now you need to get your application going. If you're probably going to need logic for starting and stopping things, whether it's with just I/O control or from the network. You're going to need to obviously know what's my algorithm for adjusting speed, what happens when the drive faults out, where's that data going to come in on a communication standpoint, what do I want to have happen in that scenario, and then on the operator interface side of the application, where am I going to monitor, status of communications? Hopefully that's something I only have to look at every once in a while, of course, because communications should just be working most of the time. And where am I going to be looking, or what screens am I going to create to adjust parameters in the drive, to take a look at diagnostics, those sorts of things. And then what other functions do I want to perform in addition to just basic control and operator interface? Do I want to log data from the machine, including data from the drive? Those are all the sorts of steps that I'm going to want to take. Okay, so it's time for me to stop showing you slides and fire up Cscape here to do a live demonstration. So let me go ahead and do that for you here. All right, I should be sharing my screen with you shortly. So what you're looking at here is just a standard Cscape program, or a program that is what we would call a demo program. This is a typical program that we might send to a customer who's interfacing with a particular drive to try and help them get started in communicating with the drive if they didn't want to do it completely from scratch. So in this case, it happens to be a XL7 controller. That is the controller that I've configured here. It happens to be a variable frequency drive from ABB. But again, we have example programs for Toshiba and Rockwell and all kinds of other drive manufacturers as well. Okay, so let's go ahead and get started. Now, the first step typically would be to go to the hardware configuration, and I'm going to do that in just a second. But I thought I would do things a little bit backwards and kind of show you one of my screens that I've got set up for diagnostic purposes, just to give you an idea of the type of data that we're going to be accessing, as well as some of the diagnostics for the communications, at least, that we have available to us. Now, in this particular example, I'm actually not using I/O signals to start and stop the drive and change frequency and monitor frequency. I'm actually using the network for that. Now, the customer's application, they don't have to do that. They could change the parameters that they're monitoring and those sorts of things, or they could leave it like I've got it configured to start and stop and change speed and monitor speed over the network. But this is a good basic start for a typical customer to get them going. So you can see what we've got here in our screen design. So I just wanted to give you a heads up and show you the type of data that we're going to be dealing with here. All right, so let's get started the right way, and that is from the hardware configuration screen, which can be accessed here from this button, this little icon at the top, or it can be accessed from the controller menu. I'm going to go ahead and use the icon. Okay, now for the example, just like I've done with most of the slides, we're going to mainly be talking about Modbus RTU because that's the most common. I'm going to go ahead and go down to the serial port section of the hardware configuration, and I'm going to hit the config button. Okay, and on an XL7, which is the controller I'm working with here, you actually have a total of 4 COM ports. You have 3 traditional communication ports, and then you have kind of a non-traditional one, which you can use by stacking a special COM board on the back of the unit. But it's 3 traditional COM ports, and MJ2 and MJ3 would be the most typical ports that you would use for doing RS-485 Modbus, and in this case, we're going to use MJ2. Okay, so the first step in this configuration was the application engineer selected Modbus master protocol because the OCS is the master and the drive is the slave. All right, so that was the first step. And then again, we've got these 3 levels of configuration: the network level, the device level, and the scan list level. So let's start at the network level. So the top part of this dialog box here, starting primarily at the left, is all about the communications parameters. RTU Modbus is a RS-485 protocol. You need to set your baud rates and parities and stop bits all matching on both sides. So generally, what I would typically do in most applications is I would find out what the default parameters are in the drive, and I would have the OCS match those. You don't have to do it that way, but that's typically what I would do in most cases, just to make things easier on the electrician if he ever needs to swap out the drive. Now, on the right here, you have your choice between Modbus RTU and Modbus ASCII. RTU is by far the most common these days. ASCII is a little bit more of a legacy protocol, although it's still supported, of course. And then in this corner here, first of all, this is a parameter that you typically aren't going to have to touch. You know, keep in mind, the OCS has been supporting variable frequency drive communications for 20 years now almost. And back in the day, there were drives that really struggled a bit with rapid communications. That's not the case anymore. But just in case you run into an older unit and you need to slow down the communications between the OCS and the drive, you can do that here. But 99% of the time with modern drives, you're just going to leave that at fast. Okay, the next key parameter here is timeout. So this is the amount of time that the OCS is willing to wait for the drive to respond to any kind of query or communications request. And I think the default is like 5 or 10 seconds, which is way too long for an RS-485 connection. I always shorten that down to about a second or 1,000 milliseconds here. If the drive hasn't responded within a second, it's probably not going to. And then here, this is the number of retries that the OCS will make when it is actually polling the drive over Modbus. So in this case, it'll do 2 retries. So if it does a try and it's unsuccessful, it'll do 2 more for a total of 3. So if the drive was powered down, for instance, after about 3 seconds, what will happen? Well, the OCS will take the drive offline. Okay. How long will the OCS take the drive offline for? Well, for this amount of time here, which is called the reacquire time. And I've set it in this case to 4 seconds, which is a reasonable amount of time. Now, keep in mind that another new feature that we've just added to the OCS I think with Service Pack 3, is the ability to, on the fly, potentially disable either the slave itself or an individual slave itself or Modbus as a whole. So you do have that option as well. But in general, I would set the reacquire time at something reasonable. If you have multiple drives on the network, the reacquire time should be, let's say, 15 seconds, 30 seconds, a minute, what have you, because while the OCS is not able to talk to that drive, the communications with the other drives will suffer. So you're definitely going to want to set that reacquire time to a level that still allows for good communications with the drives that are up and running, but then after a reasonable amount of time gets the offending drive back up and going again. Okay, so again, just to recap, baud rate, parity, data bits, Modbus RTU, use that alone. Fast, leave that alone. Set your retries. 2 is a good number. Timeout of a second is a good number as well. So what do we have down here? Update interval. I like to leave the scan at automatic. That means the OCS is automatically going to handle polling the drive, reading and writing the parameters as they're needed. Okay. And if you set this interval to automatic and the interval to 0, it means the OCS is going to do it as quickly as it can. So it's going to scan all the information that it's been configured for. And when it's done with that list, it's going to go back and do it all again. Okay. So these are some good parameters here. One last note. I talked about the fact you can assign a variable for disabling Modbus in general. You can also assign a variable, and I highly recommend this, for getting real-time diagnostics on the communications health over Modbus. And we'll show you, that's some of the data that I put on that screen that I showed you a minute ago. Okay, so this is network level configuration. On the device level of configuration, this is where we add each drive that we're going to be talking to. In this case, I just have one here. Maybe that's all we're ever going to be talking to. So we can give that drive a name. It does not have to be anything specific. In this case, I gave it the model number of the drive that we're talking to. You do need to configure a Modbus ID, which typically is between 1 and 247. Okay, needs to be unique, needs to match with what the OCS is expecting. And then this is where we get down to what we were talking about earlier, the style of Modbus address that's in the user's manual for the product. Now, Modbus 5-digit addressing is by far the most common. 6-digit addressing is more common for Modbus over Ethernet, but I guess there's some devices that support it as well. And then if you scroll down a little further, you'll see we've also got some of those generic decimal address and hexadecimal address options that you might find in the back of your user's manual for your drive. That being said, if you're not sure, stick with Modbus or Modicon 5-digit addressing scheme. That's by far the most common. Okay, here's that disable variable that you can assign. I haven't done that here for disabling communications with this particular node on the network. If it goes down for some reason, maybe you're talking to multiple drives and one of them is down for maintenance or one of them has failed, you're going to want to be able to disable that drive during that eventuality and then bring it back on again manually using the same variable later on. Okay, and then there's additional status information that's geared specifically towards this slave. Okay, so this is the device level configuration. Now, lastly, we have what we call a scan list. This is all the data, and there's not a lot configured here. Again, this is a basic application. This is all the data that we're going to be reading and writing on a regular basis. So let's take a look at what's already in here. Okay, the first thing on the list here is a variable labeled CV_Hertz. So CV, in my case, I programmed this. So I programmed it to mean control variable for frequency. So this is the variable that is going to be sent from the OCS to the drive to control the frequency of the motor. Okay. Now, in this particular drive, the ABB ACS 350, that particular Modbus address in the register map, in the parameter map, is 40,002. So we're going to be writing the frequency value to Modbus parameter 40,002. Now, where's that data coming from? Well, it's coming from local OCS register 50, okay, which again, I've given a name of control variable _Hertz. Now, this is labeled as a polled read-write. Why is that? Well, we're going to be reading this parameter on a regular basis. And then when it changes for control purposes or whatever the case may be on the OCS side, we're going to write it when it changes and then read it back again. So you're going to find typically read-write type options here on the update type for this sort of variable. Now, what you won't find, and it's a feature request we do have in there, what you won't find is a write-only type polled type connection, okay? So what does polled mean? Well, polled means that the OCS is automatically going to handle reading and writing this information in the background. There's nothing the user has to do once they've added this value to the poll list or to the scan list. If you only want to do it on demand, you could configure it as being a triggered read or a triggered write, which then will have an additional bit that you'll need to configure to a variable for triggering that read or triggering that write. But most of the time, I just leave it on polled read and write. Okay, so this is the mechanism we use for writing the frequency to this particular drive. Now let's take a look at another read-write value that's on the list here, and that is the control word. So the control word is used by a lot of drives, and it contains typically the bits that are used to start or stop the drive or motor effectively, or change direction, forward and reverse, those sorts of things. Those parameters are almost always, those bits are almost always mapped into what's called a control word. And that is, in the case of the ABB drive, mapped to Modbus 40,031. And internally on the OCS side, we mapped it to register 53. Keep in mind, I was able to map this wherever I want to put it. On the OCS side of things, it doesn't matter. Okay, I've got 50,000 registers to work with. On the drive side, it needs to be the right parameter because we're going to be telling the drive to start and stop or change direction. We need to be writing that data to the appropriate register on the drive side. Okay, and again, this is a polled read-write. Now, let's say that we wanted to monitor, let's say, the frequency back. Okay, what is the actual frequency that the drive is operating at? Okay, not what we're commanding it to be at, but what it's actually operating at. Well, I'm going to go ahead and add into the list here. I'm going to go ahead and show you how to add another parameter. So I happen to know from my manual that in this particular drive, it is address 40,103. That is the frequency, the actual frequency. And then in my application, I've mapped this into register 55. Okay. And again, this is because I'm just reading this value back. This is not a read-write. This is a read-only type register. Okay, so that's all that's really required to add, parameters to the list. Now, in this case, these parameters are kind of spread around a bit. I'm reading and writing one word at 40,002, another word at 40,031, another word at 40,103. If I had a series of parameters that were near each other, then I would do a single read, for instance, and instead of, reading one register, I might read 16 registers and map them into a group of 16 consecutive registers on the OCS side. That would be far more efficient than having a bunch of entries in my scan list. And if there's some information in the middle of that group of 16 that I don't care about, then fine, I'll ignore it. But maybe there's 7 or 8 parameters I do care about, and I can access them all, in this one read command, one entry on the scan list. Okay, so that's what's required on a scan list standpoint for configuring what data the OCS is going to be polling on a regular basis. Now, one last thing I want to show you, and that is you don't have to have all your information in the poll list or scan list if there's drive information that you only care about once in a while. So I'm going to go to a screen, back to that screen I showed you at the beginning. All right, let me go ahead and make my screen larger here, and I'll zoom in a bit. Now I'll just leave it at its current size. Let's say we want to monitor the current of the drive, the actual current of the drive, but we only want to monitor the current of the drive when we're on a particular screen on the OCS. We don't want to continuously poll it. We only want to look at it on demand, if you will. Well, one option you have is you can add that. You can add a graphics object to the screen, map it to that particular parameter in the drive that is not already mapped into, it's not included in the scan list already. It's not already mapped to an internal OCS register or variable, and you can just have it up on the screen. And then when you're viewing this screen, you'll see the data. When you're not viewing this screen, the OCS isn't paying any attention to that parameter. So let's go ahead and do that now. So I'm going to add a data field. I'll just do that quick and dirty here. All right. I'll double click. This is going to be a read-only data field. I'm going to be reading current. Okay, it's going to be a decimal value. That's accurate. Let's say in the case of the drive that it's going to be giving me 1/10 of an amp. That's the formatting for the information. So if it sends back 10.5 amps, it's going to send me 105. So I'm going to want to put an implied decimal point as I display it on the screen. My engineering units are going to be in amps, so I might as well put an entry for that here. Let's go ahead and make the size a little bit bigger of our data. And then more importantly, where's the data that we want to pull from? Well, instead of pulling from internal registers, instead, we're going to pull from directly the ACS 350, okay, that has been configured on a device level via Modbus. And under address, I don't enter in a register here, not a Horner register at least. Instead, I'm going to be adding in a Modbus address, which happens to be 40,104. Okay, so I've now configured a data field that will display the current with 10th degree in 10th degree amperes. All right, it'll directly grab the data from the drive over Modbus. It won't map it into an OCS register. It won't pay attention to this data or read this data unless the OCS is displaying this screen. Okay, and that was pretty ugly data field, you'll have to admit, but instead of prettifying that, I think I'll just wrap up the demonstration there. So that is kind of a wrap up of our program for today. I hope it was a good mix of general information on the sales side, along with some more specific technical information on how to configure things. We have gotten some good questions. We've had some of them already answered. I want to give a shout out to Tom Philippek. Tom is one of my colleagues at Horner. He happens to be located in the Minneapolis, St. Paul area. I'm in the Indianapolis area, and Tom has been helping answer some questions, which is fantastic. Terrific. So let's see. Any questions that I should be answering, you think? Marcy and Casey?
I don't think so. I think we got most of them taken care of.
Very good.
And just so everybody knows, there's a Q&A tab that all those will show up on. I believe there's an all-in answer tab for the different groups anyway, but I believe it pulls up the chat tab by default.
Okay. Another thing that I'll mention is we had let's see. So answers to our poll questions. Do we have the ability to show the results, Marcy, or are we the only ones that can see that?
Oh,
So only us?
Look under the close tab.
Okay, there's close. I can see it. How do I get it on the screen?
I think the attendees can just look under the
The
closed
attendees
ones
can
as
look
well.
at it. Okay, good enough. Sorry about that. Okay, so if you're interested, you'll see the results of the 3 polls. We've got about 50-50 in terms of those who have used the OCS with variable frequency drive before, and Modbus and Modbus TCP are the 2 most popular protocols. And then you'll see Ethernet IP as well. That's also quite popular. I'm impressed. We've had 4 CAN open users out there. That's great. And then a couple that haven't used VFD networking at all. So CAN open can be pretty complicated, but it sure is a nice network from the standpoint of performance. The reason that OCS does not interface with drives over Ethernet IP is because the OCS cannot be an Ethernet IP scanner. That's what's required on an Ethernet network in order for an Ethernet IP drive to be controlled. And at least in terms of built into the OCS, we don't have the ability to be an Ethernet IP scanner. We can be an Ethernet IP I/O device. We can interface with a Rockwell Logic CPU and access global tags out of the Rockwell Logic CPU, kind of like an Opera interface might. But we can't, at this point, we can't directly be an Ethernet IP scanner, although there are third-party devices that work rather well from people like Real-Time Automation, as well as Hilscher and HMS and others that can be put in between the Ethernet IP network and the Horner OCS that would allow an OCS to be an Ethernet IP scanner, but it does require an extra component. Okay, and then in terms of the brands that people have used, looks like ABB, Rockwell, Schneider, Lenza, all have been used before, Toshiba also. So, and then there's lots of other brands as well.
Hey, Chuck, you got one more question that just came in.
Sure. Have you done a demo on an invertec drive? I have not, I don't believe. But I know invertec is another one of those drives that has some great communication options available. I believe invertec may even offer CAN open as one of its standard protocols in addition to Modbus. But one thing I will say that if you're one of our reps or distributors and you happen to sell a brand of drive and we don't happen to have a demo program for that particular drive, we're always more than happy. If you can loan us a unit for a week or two, we're always happy to develop a demo application for it. And we've done that many times. It's rare that we buy them. We do have a few that we've acquired over the years, but generally, if you can loan them to us, then we can set up a demo. Okay, I think that wraps up our presentation for today. Thanks for the great questions and for the poll responses. I appreciate your participation. Just a reminder that every Tuesday we do a OCS, or we do a YouTube live stream. And starting this upcoming Tuesday, we've got a new registration process for those that we'd love you to participate in for signing up for the YouTube live sessions. And pretty much every week we'll cover a different topic. Usually it's something relatively technical. We mix in a combination of a few slides and a lot of demonstration and some product demonstration in addition to software demonstration. So we hope that you'll join us for one of these weeks and find it valuable. And in 2 weeks' time, we have another webinar coming. Which one is that, Marcy? They're all running together for me.
That's a good question, Chuck. Hang on.
I think
They're running together for me too.
Which reminds you that, or I will remind the viewers that you can always go to our website and rotating through, we have a listing of all the month's sessions.
It's a good one. It's introducing our new app.
Ooh. You won't want to miss that for sure. Even if you can't join us for our YouTube sessions, we're going to be introducing a new Horner mobile app. And 2 weeks from today will be the big launch of the announcement of that product. You heard it here a little bit early, but you'll get to see a full demonstration of that. I've been playing with it for several weeks now, and it's worked like a champ. So I think you'll be excited to see it. So with that said, as a little bit of a teaser, thanks for joining us, and we'll look to see you again soon.